Applications of systems of inequalities. So last time we talked about how to graph linear inequalities. Now we're going to talk about the applications of them. Applications of systems of inequalities. So what we're going to do is we're going to write inequalities to represent these word problems, and then we're going to graph them on a grid. So first it says, example 1, Lewis receives a gift card worth $100 to an online retailer that sells digital music and games. Each song costs $1 and each game costs $5. He wants to buy at least 30 items with this card. How many games and songs can he buy? Give 2 possible solutions. So first, again, let's define our variables. So it says it's asking you how many games and songs can he buy. So that means X has to be the number of, let's say, games, because how many means number of, and let's make Y the number of songs. Okay, now that I know my variables, we can start to break apart this word problem. So Lewis receives a gift card worth $100. Guys, that's a total. So this gift card that he has is a total of $100. So I need value. I know that each song costs $1 and each game costs $5. So if I take 5 times the number of games, I'm going to get the total cost of my games, plus 1 times the number of songs, so that's really just Y. That will give me my $100, but this is not an equation. This is an equal sign, or this is going to be an inequality, because I don't have to spend all $100. If this is a gift card, you can go up to $100, just not over it. So you could spend $20, $30, $99. You just cannot go over that 100. That means this has to be less. This total money right here must be less than the 100. Now the question is, can you actually spend the full amount on the gift card? Yes. So this is actually less than or equal to 100. Now let's talk about the second equation. I also says I want to buy at least 30 items. So this is also a total, but this is just talking about the number of items. It has nothing to do with value. So this is going to be the number of games, which is X, plus the number of songs, which is Y. So number of games plus number of songs. And if I want to buy at least 30, that means I want to buy this many or more. Think about grades. If you want to pass, you need at least a 70. So that means a 70% or higher. So this has to be greater than or equal to 30. Now that we have our inequalities written, we need to graph it on a grid. So first, before we do anything, let's label our axes. So the x-axis is here. X equals the number of games. So this on the X will be number of games. And then on the y-axis, we will have number of songs. Number of songs. There we go. Now we can start to graph. So trying to put these into slope-intercept form is not the easiest thing to do. When you have standard form like this, it's actually easier to graph with intercepts. So let's talk about the 5x plus y less than or equal to 100. If I want to find the intercepts, I'm going to pretend this is an equal sign, and I'm going to solve for x and y. So for the x-intercept, that means that y is equal to 0. So I would have 5x plus 0 equaling 100. Well, I don't need this, so really all I need to do to find the x-intercept is to divide by 5. So my x-intercept is 20. So that means my coordinate point would be 20, 0. I also need to find the y-intercept. So for the y-intercept, that means that your x value is 0. They're always backwards. So this is 5 times 0 plus y, giving me 100. That'll give me my y-intercept. Well, 5 times 0 is 0, so all I really have is y equals 100. So that means my y-intercept is 0, 100. Now I need to do the same thing for my inequality 2. X plus y greater than or equal to 30. So again, let's find the x-intercept. That means that y is equal to 0. So we're going to have x plus 0 equaling 30. Well, that's nothing, so x is 30. So that means my y-intercept is 30, 0. And then for the y-intercept, that means that x is equal to 0. So we're going to have 0 plus y equaling 30. And again, this 0 I don't need. So y equals 30 also. So my y-intercept is 0, 30. So let's use all four of these intercepts to help us figure out what our scale needs to be on our grid. So let's look at the x's. I have an x-intercept of 20 and an x-intercept of 30. That means I need to get up to 30 on my axis. So there's 14 grid lines here. So this is going to be 0. So 14 grid lines means I can't go by 2 because 14 times 2 is only 28. I'm a little short. So we're going to go by 3s, but I'm going to skip every line. So this is 3. So this will be 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Then I'm going to also do the y's. Same way. I have 100 and I have 30. That means I need to get up to 100 in order to let this graph fit on my grid. So again, there's 14 lines up this way. So the easiest thing we're going to be able to do is probably by 20s. Because if I try 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 60 75, 80-ish up here, I don't hit 100. 10s won't hit it. 10s will hit it perfectly. 10, 20, 30, 40, 50. So again, I'm going to skip every other line. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. I skip every line because if you mark every single grid line, your numbers are going to get really squished down here, which is why I skipped every other grid line. Now that I have a scale, let's graph. So let's graph the blue one first. I have a y-intercept, an x-intercept of 20, 0. So that would be, let's see, 18, 21. So 20 is about here somewhere. And then I have another y-intercept of 100. So that would be here. I'm going to connect those 2 points, but you have to be careful. Since this was a less than or equal to, that means this is going to be a solid line. So I'm going to connect these with a solid line as best I can without a ruler. And then we will talk about shading at the end. Now let's graph the red one. So 30 and 30. So I have 30 on the x-axis and I have 30 on the y-axis here. And again, this is greater than or equal to, so that means this guy is also a solid line. So let's try to graph this one. Okay. Now let's discuss shading. So I'm going to shade in yellow. So for the blue, this is a less than. You have to be careful of this y. If y is negative, you need to flip this symbol to the other direction. Since y is positive, this is a less than. That means you're shading below. So my blue line will shade this way. Since this is the red one, this is a greater than, and the y is positive. That means you're going to shade above. So my red line shades this way. Well, the overlapping is just inside this triangle. That's the only place that those shades overlap. So that would be the solution area for this system of inequalities and nowhere else. Now, the last part of this question said to give 2 possible solutions. Well, I'm going to pick a point. I'm going to pick this point here. As long as it lands in the shade, that's a solution. So I could have 6 games. So 6 games. I could do 6 games and 40 songs. That'll keep me under my gift card limit. Or I could also do, even let's say this point. I could do 3 games and 80 songs. There's lots of solutions, but those are 2 of them. So I want you to try example 2 on your own. I'm going to give you your variables. That way our graphs will look the same, because if you use different variables, your graph will look different. So I'm going to make X the number of bracelets she sold. And I'm going to make Y the number of earrings she sold. Now try to see if you can get the graph and some possible solutions. Here is the graph that you should have come up with. Your possible solutions can be many, but as long as they're in this yellow area, you are correct. That will give you your solutions for this situation. Let's look at example 3. A carpenter makes bookcases in two sizes, large and small. It takes 4 hours to make a large bookcase and 2 hours to make a small one. The carpenter can only spend 30 hours per week making bookcases and must make at least one of the large and more than 3 of the small each week. Write and graph a system of linear inequalities that represents this situation. So again, before we start writing, I need to figure out what my variables are representing. So what is this carpenter making? Because I don't have an actual question here. So I got to ask myself, what is this all about? This is about bookcases in two sizes. So I have large and small. Well, what I don't know about them, these are the numbers. I don't know how many I'm making. I know I have to make at least one and more than 3, but I don't know specifically how many we're making. So this is the number of, let's say, small bookcases. And we'll say this one is the number of large bookcases. Okay? Now let's talk about inequalities. So I know, let's look for totals. I can only spend 30 hours per week making bookcases. There's a total of 30 hours. So how long does it take me to make a small one? It takes me 2 hours to make a small bookcase. So 2x plus, it takes 4 hours to make a large bookcase, 4y. If all you can spend is 30 hours, that's it. You can't go over 30. So you have to be less than 30, but you could actually spend the full 30 hours working. So this is going to be less than or equal to 30. The total time it takes, less than or equal to the 30-hour limit that you have. Now let's look for another. I might not have any more totals, but I do know I must make at least one of the large and more than 3 of the small. Well, at least is an inequality symbol, and so is more than. So these are two separate inequalities. So if I need to make at least one of the large, and y is my large, so y has to be greater than or equal to 1. We talked about the at least earlier. Think about you need at least a 70 to pass. Then you need more than 3 of the small ones. So the small is x. Now more than 3 is just a strict greater than. I don't want 3 and only 3. I want to be higher than 3. So this is a greater than, not a greater than or equal to. So these are the 3 inequalities that we're going to work with. Well, let's first get our graph set up before we start figuring out numbers. So my x is the number of small bookcases. My y is the number of large bookcases. And then I need to figure out my numbers. So this blue one is really going to control how high on my axis I have to go. Because on the red one, all I need is a y value of 1. And on my x one, all I need is an x value of 3. So it's really the blue one that's going to make a big difference. So if I find the x-intercept for the blue one, that means my y value is 0. And I'm going to pretend it's an equal sign. When you find the intercepts, pretend it's an equal sign. So 4 times 0 is 0. So all I have is 2x equals 30. So to get x, we're just going to simply divide by 2. Get x equals 15, which means my intercept is 15, 0. So for my y-intercept, we're going to make x is 0. So 2 times 0 is 0. So 4y equals 30. Divide by 4 on both sides, and we end up with y equaling 7.5. So it is a decimal, but that's okay. Now we know our constraints. So for the x-axis, I need the highest number I have is 15, because this is just a 3. So I need to get to at least 15 on my x-axis. So I'm going to go by 2's. So 0, 2, oopsie. 0's on the corner, so this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, now for my y's, I need 7.5 because this is just a 1. So the highest I need is 7.5. Well, I can go by ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and now we're ready to graph. So if we graph the blue one, my x-intercept is 15. So these are going by 2. So 2, 4, 6, 8, 10, 12, 14. So 15 is right here in the middle. And then on my y-axis, 7.5. So 4, 5, 6, 7.5, also in the middle. This is a less than or equal to. So this means we're going to have a solid line. So we're going to connect these 2 points with a solid line. And that we're going to talk about shading at the end. So for the y, remember when you have y and a number, this is a horizontal line at this number. Now, it is a greater than or equal to, so this is also solid. So at 1, I'm going to draw a solid line all the way across where y is 1. And then last, we have the x and the 3. If you have x in a number, these are vertical. And this is actually just a greater than, so this is actually a dashed line. So at 3, so let's see, 2, 4, so 3 is right here in the middle. We're going to have a dashed line all the way down the middle. Hopefully a little more straight than that one. Now let's talk shading. So for the blue, this is a less. So, and the y is positive. So for a less than, that means we're going to shade below. So that means this direction gets shaded. For the red, I have a y greater than, and the y is positive, so we're going to shade above. So that would be up here. And then for the purple, we have a y greater than, which is also above. But since it's vertical, that means we're shading to the right. So we're going to shade this way. So if the blue shades down, the red shades up, and the purple shades to the right, that means they're all overlapping here in this little bitty triangle. Okay. Now, last but not least, let's talk about some solutions. So all of these inside are solutions. Those are the easy ones. This point here, that is a solution because it falls on 2 solid lines. This point here is not a solution because it falls on a dashed line. This one is also not a solution because it falls on a dashed line. This boundary point, any of these on the red, that's good to go. Any of these boundary on the blue, those are good. But any of these boundaries on the purple, that is not a solution. So the yellow shade is the obvious solutions. The boundary lines, you kind of have to think. If it falls on a dashed line, it's not going to be a solution. So I want you guys to try example 4 on your own. Again, I'm going to give you the variables. That way we know that we're going to keep the same answer. So I'm going to label X the number of soil bags. And we're going to name Y the number of plants she buys. See if you can come up with this graph on the right. This should be your solution to this problem. And that is graphing applications of linear inequalities.